Hello, folks. I think it's going to be a short night, and we're going to give imaging Saturn and Jupiter a try. In fact, I've already started imaging Saturn, and clouds are coming in. I can tell because I'm getting alerts from PhD2, and as I'm guiding. So here we are outside, and let me share my screen. I can do that in a minute. There we go. And what we have is Saturn is right here at the top of this page. Kind of hard to see of this view of this surveillance camera. That's the moon, which is flushing out the sky. That alert sound that you are probably hearing is PhD2 telling me that clouds are interfering with my target. So if we go over to PhD2, here we are with our imaging of Saturn. And let's bring it back and center it a little bit better. Okay, I'm capturing as many frames as I can get at 40 frames per second. I'm down here in the bottom left, but I'm capturing as many frames as I can in 2 minutes. Since this says Saturn, I can get by with a 2-minute video. So it looked like I was getting around 5,000 frames at 40 frames per second. And I'm doing a run of 15. And then I will stack each one of those in auto stacker. And I'll apply wavelets and a few other tweaks in Registacks. I will then take them into WinJupos and do a derotation. And hopefully I'll have a respectable image if the clouds allow. So let's bring up PhD2. I am guiding, and over here where it says star lost, it already tells me that I lost my star 8 times. This is Saturn, and it's almost in the bullseye of my guide camera. The problem with multi-star guiding on a night like tonight is Saturn is so close to the moon that it's polluting out. Well, it's polluting the sky so bad that I'm having a hard time finding a guide star. And so I've got a 3-second image as well, so it's pretty rough when you can't at 3 seconds find a star in your star field. But between the brightness of Saturn and Jupiter, which is rising, but between the brightness of Saturn and the moon, there's just very few stars that are that you can get. And any kind of a cloud at all is going to even be more lit up because of the moon, which doesn't make it easy to, which doesn't make it very easy to image. But I don't expect much, but I love doing it, so that's why I am. And let's go back to SharpCap, and as you can see, we have got about 1,000 frames. We can go ahead and put the mount to sleep. Not the mount, but the surveillance camera. Where did mount come from? I get crazy speech-wise at night, and it gets worse as the night goes on. Saturn, though, is holding pretty steady. You can tell by its wobbling. The scene conditions aren't great. But it's kind of looking at Saturn through water. And Yet it's possible, because of software, to take these wobbling images, which are AVI files. An AVI file is a movie file. It's a video. So I'm actually taking videos, and the video's made up of frames, and I'm taking 40 frames a second, and in a 2-minute period I have about 5,000 of those frames. I'm right now at 4,800 frames, and it stops. So I'm getting right close to 5,000 frames, and it started taking another one. I'm going to open up Explorer, or not Explorer, I don't know what these things are called in Windows. I'm a Mac user, but software that I use for or have to use for astronomy. Most of it's written in for Windows only. Not all, but the vast majority. And okay, so so far we got 1, 2, 3, 4, 5, 6, 7, 12. Up here it says 12, 8, 9, 10, 11. Well, we have 11, and this will be the 12th one. It's taking it now. And we're going to do 15. Once we have 15 of these Saturn pictures, I'm going to head over to, by the way, it's so low in the sky that I am surprised I'm getting any stability. The clouds are trying to cover it up. You see it dim and then get a little brighter. And that is cloud working on it. But when we get our 15, then I'm headed over to Jupiter, and clouds completely are wiping that out. Now I'm really surprised that PhD is not giving me a lost star error. It is interesting, because we're losing sight of Saturn. Okay, we took that, that was 12, so this I guess we're working on 13. We may be working on 14. Let me see. Alright, we have 13, so we're working on 14, and then we'll have our 15 frames. We'll have our 15, a stack of 15 AVI files. We'll have at 5,000 frames times 15, that's how many total frames we'll be playing around with. But each one will be stacked independently, and then they'll be combined eventually to produce one image. Both Jupiter and, well, all the planets rotate. Jupiter rotates faster than Saturn, and with Saturn I can get by with 1 minute periods for exposing, so I take as many frames as I possibly can. And now I'll be able to go at a faster frame rate with Jupiter because it's brighter, and the brighter it is, the more I can adjust my exposure and increase my frame size. Longer exposures slow down the frames, the acquisition of frames. There goes our planet. And what I'll end up doing is probably saving, depending on the quality graph, I'll be saving between 10 and 15, maybe as high as 20% of the individual frames in each of these videos, and I'll get rid of the rest. I'll just take the top 10 or 15%. So if I got 5,000, then that means I'll have between 500 and 1,000 frames that I'll retain from each one. You already saw where the clouds are going to do damage to part of the frames, so they'll just be discarded. We are on the 15th one right now. No, we're on the 14th one right now. Then we'll have 15. So we're at 14. We have 14 and we're waiting to do 15. There it goes. There's the beeping, so we're losing stars, our guide star. So the stars are, we'll restart this. Restarting this doesn't really do anything, but just it doesn't make any changes to PhD2 or affect it in any way. It's just a visual thing. You just clean it up. Itchy nose. My guiding's going okay, not great. But then I'm not multi star guiding either, and I've got the clouds affecting things, and scene's not good, so I don't know that I expect it to be much better than that. That will help keep the Saturn position right where we need it, which is in the center. Okay, we ought to be we're capturing, I think, the very last frame, and we're at 1,000. When we get to about 4,800, it should be done. Then we'll go take a look-see at Jupiter. I wonder where Jupiter, I wonder if Jupiter's going to be right next to the moon. I bet it is. Let's look and see exactly where it is. So hang on a minute. I know you're in the dark right now, but I'm booting up a planetarium software program that you'll be able to see. It's still coming, so hang in there with me. Gosh, this is slow. Well, while that's booting up, we'll just head back to our planet. We are live imaging Saturn, if you just joined us, and we are finishing our 15th video file, which was our goal, and it should finish up in about 800 frames. It looks like we're getting about 4,800 frames over a 2-minute period. At 40 frames a second, which isn't really all that hot or good. Okay, we got almost 4,900, and it's our capture run is complete. We've got everything that we need there. So now I want to go back to the planetarium program, because I may not try Jupiter. Here's the planetarium program. We're in the south. Okay, there's the moon, and there's Jupiter, and here's Saturn. So the moon, let's see if my let's go outside of the surveillance camera, and there's Jupiter now. Saturn's gone on up here, but there's Jupiter. So let's head there. Our telescope's aimed about there, and we're going to move it to there. So let's go to our planetarium software that I use to slew, and let's go to Jupiter. I'll just click up here, Jupiter, And let's slew there, and let's look at our telescope. And oh, it went to sleep. Let's go back again. Okay, well, let's move there, and I'll bet you anything, I know PhD's crying because I slewed in the middle of tracking. There is Jupiter, and I need to move it around a little bit because it's not where I want it. So let's I want to put it about right there. So let's go I think west, and I need to move this down to about 5/10 of a second. We'll go faster. Alright, let's go west. That's going to be the wrong way. And let's try south. Up. So it's going to be east and north. We're going at sidereal. Let's go 2 times sidereal. So we said east and north. So north and east. West and north. Come on back. That's how to do it. Come on up there. Right there. One more edge. There we go. Okay, it should be smack dab. In fact, I'm going to go ahead and start. Well, let's go on over to Jupiter. Okay, there's Sharp Cap. Let's lower our gain. Let's bring it up to 300, and let's lower our exposure to a little more, and let's position, and let's go see if we can't find a guide star. Let's stop guiding. Let's start looping. Let's search for a guide star. Found something. So let's guide, and I want to clear all this out again. We'll start from scratch. So we are guiding on Jupiter, and we're not as centered as I want. So okay, and what we're going to do here is we're going to have to change our run. We want to do 15 again, but we're going to do it in 1 minute. So we're going to take as many frames as we can in 1 minute, but we're going to be going up to 90 frames per second because we're able to take it at 10.8 milliseconds instead of 23 or 4 milliseconds. Which was the guide speed. Also, we're going to lower the noise that's inherent with these high gains because we went from 350 to 292, and there is no giant red spot until around, I think, 11:30. And I was talking to a friend of mine from Roper Mountain Astronomy. I think he was telling me that it's going to rotate around 11:30, and so if the clouds will allow, I will stay here for an hour. Doubt that I will be live for an hour, but I might just be. Okay, we finished that run. I forgot to look and see how many frames, but it should be every bit of 4,800 because we were doing 40 and now we're doing 90, and we're doubled the frame rate, and we were doing 4,800 in 2 minutes, so we doubled the frame rate, so we ought to do at least 4,800 in 1 minute since we are recording twice as many. I don't know if it makes any sense, but I think we're going to get 4,800 to 5,000. So right now on this run, we're at 35. And we can go ahead and put you to sleep. And we're at 48. We got 5. Should be about done now, though. There we go. We had about 5,500. That's about right. Come on, giant red spot. The giant red spot is the storm that'll be coming around over here on Jupiter if I have this camera oriented right. And it's the historic storm. Its scene is really not good at all. We're all over the place. And the moon is at 99.7% illuminated. So it is as full as the moon will become. At some point in time, in the next 24 hours, it will hit 100%. It may be daytime. But, okay, we got another 5,400 frames. And, that jumping that you just saw is a result of PhD2. It's a good thing because it kind of keeps the mount in a position where it can keep your target centered. But it also sends corrections to the mount. And sometimes due to seeing, the correction may come, which moves the mount, and you'll see it bump a little bit. I'll bring you up to, it happened right here, that jump, and it made a big correction down here. You see the pulse that it sent, so that's why it jumped. So it's a good thing and a bad thing. But the best thing is that AutoStacker sorts it all out. So don't worry about it. So we're live imaging. We're doing a live imaging run for Jupiter. And we are going to take 15 AVI files. I'm asked, why do I do AVI and not SER files? And I don't have a good answer. I'm told that the SER files have a lot of good data. There's a correction that PhD just sent. And but I'm accustomed to using AVI files. And then I'm also asked, why do I not use FireCapture instead of SharpCap? And it's because my first planetary imaging software was SharpCap, and I'm very comfortable with it. I've used FireCapture, and it's so similar, but I'm just not as comfortable with FireCapture. They both do the same thing. That's what I do. I do use the focusing routines that SharpCap has. I'm not sure what FireCapture has, but I like to run the contrast edge detection, and it kind of helps me to make my focus adjustments. And I'm going to take this box and I'm going to make it a little bit wider so it can catch the edges. And I tell you, it's hard to do any focusing when the scene is this pitiful. At any rate, this is my focuser, electronic focuser, and oh, clouds are playing a role. Here they come. Let's add about 10 steps. Sleep now. Let's add another 10 steps. It's not improving things. The best is 18, and let's go down and let's go the other way. We're going to go back 30 steps. Let's change this so that we're cutting this in half. Bring our focuser back up, and let's go back 10 steps. Let's go back another 10. I think I'm headed in the right direction. Ooh, there goes clouds. And you just have to let this run for a long time and then make a little adjustments to your focuser, because you have to factor in the fact that scene conditions kill focusing, and the better the scene is changing constantly. So all in all, I'm gonna probably come back I'm thinking let's move down to this side. Let's move up to this side. Okay, let's bring our focuser back. I'm going to take it back down to 888. I'm going to take it back to about 58. And that's where I'm going to leave it. Okay. Let's see how many we've taken of Jupiter. I forgot to change the name to Jupiter, so they're all called Saturn. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, and this will be the 10th one. While we are taking these other frames, let's bring up Auto Stackert. This laptop that I have outside is not a I think it has an i7 processor. It's slow, and I hate really waiting. Let's just take the first one, and I'm going to kind of scrub through this a little bit. I'm going to use my arrow key, right arrow key. Oh, they look terrible. Up. These are as bad as I've taken. just going to go with that one. We got planet check, dynamic background, Laplace local. Alright, we're going to analyze. We're going to process the very first Saturn that I took tonight while we're also doing a live imaging run on Jupiter. As you can see from this quality graph, there's a line that goes right down here through the middle. It's a horizontal line, and this staggered graph represents all of the frames. These frames that go up are really better frames. These that go down here are horrible frames. It may be when the clouds came, it just may be poor seeing, it may be just combination of clouds and seeing. So if I took 5,000 frames and half of them, it looks like it cuts, the graph cuts this horizontal line about halfway, which means that about half of these frames are above the line and half are below. But I think what I want to do is I want to take the frames, there are not many of them, that are in the top 25% and just get rid of the rest. So that's what I'm going to do. I'm going to take the top 25%, and that's what I'm going to be working with on this image. And that might be a grace is plenty. I may have to come back and try 10%, because when I went through here I didn't see many that I thought was really worth a flip. Now what we have to do is we have to put alignment points on Saturn, and I do a automatic kind of a placement, and on the planets I use normally 48 with my kit, and I'm going to put some outside Saturn, because this, we saw where Saturn moves outside the frame, outside of this, when it's being corrected by PhD and just due to seeing. And that's all I'm going to do, and I'm going to click on stack. It is going to take a few minutes. Stacking takes the longest time, and then it runs real fast. While it's doing that, I'm going to bring up the surveillance camera, and I'm going to look outside and see if I can see clouds. I don't think I'm going to be able to, because the moon's so bright. I don't know. But Jupiter's up here and Saturn's up here, and don't know. I can always go look at the moon. So we're done. Alright, I'm going to go ahead and just put that aside, and we're going to bring up Registacks. And we're going to select our file, and that means finding the directory where the file is, and we're going to go down here to this external drive, and there we are. There it is. No stretch. So that folks is our Saturn that's been stacked in auto stackered. And what we're going to do now is I'm going to run RGB balance and just click on, you can see that the blue, the green, and the red channel are doing their own thing, and when I run auto balance they'll be a little more aligned so that they're kind of matching up, but this is closer to the colors that we're looking for. And then I'm going to flip this because I do not like its orientation, and let's move it over here about there, too much, about there. I kind of like that angle, it's good. And then I'm going to boost the color a little bit, and I'm going to drag this histogram. It's a levels slider. I'm going to grab it about there and stretch it. It's a little brighter. May do that just another tad. Stretch it again. Okay. Then I'm going to go over to gamma, which is a curve, and I'm going to right click here, and I'm going to add a little contrast curve, not much. That's it. And get rid of that. We're done there. Then I'm going to go over to the next step is to apply wavelets, which is where you're going to see if you have an acceptable image. I can already tell you it's going to be okay, not great. It's going to be typical for the scene we have. But you want to have linear checked. You want to have Gaussian checked. You want your initial layer step 1 and increments at 0. That's important. This fine-tunes the small details, and this is fine-tuning the larger structures in your image. And as you go down, it's incrementally going to apply a sharpening effect to larger structures incrementally, in a linear way. So once you set some of these sliders, you can save them and then come back and use them. So I'm going to see if I can find, I've got I'm going to use this setting that I use for Jupiter and just see how that looks. And it shows some pretty sharpening, pretty aggressive sharpening here. It's just not a good scene night, so it's just not a real good picture. And derotating 15 of them isn't going to make much of a difference. I could work and try to drag this one up a little more, because this is I don't need that anymore. Let's get rid of it and just work on the smaller detail structures. It seems to get by with less noise. I've applied a pretty aggressive noise thing too. Let's try this a little more. I'm just going all out to see if I can't resurrect the dead. Oh, I forgot. Dadgone it. Okay. I'm not going to, but I need to go out and adjust my atmospheric dispersion corrector. I moved those knobs fiddling with the thing earlier today, and so I need to go back and readjust that. I see some I see some effects of that in this image, but I'll go ahead and do all, which applies this to the whole image, and then I'll save it. And I'm going to add underscore REG for Registax, and I'm going to go ahead and save it in that same directory. because I'm going to come get it later and go ahead and derotate inland Jupiter. So let's go ahead and put this one to sleep. How are we doing with Jupiter? We have now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have the 15th, and it stopped. And I'm going to continue keeping the mount on Jupiter. How close are we to a transit? I have no idea. Let's pull up our planetarium software and find out. Okay. Oh, a long ways. It'll transit here when it crosses the southern meridian, and we're right here right now. So I'll click on Jupiter. Let's see. And let's go to info, and let's go to data. The transit begins at 1:23, so I will have gotten everything I needed by 11:30, by 12. So I'm not going to have the only problem with the transit is you have to flip your mount, and I don't like to take a series. I don't want to take 7 images on this side of the meridian and 8 on that side of the meridian to get my 15, because then you have to flip. You're going to have to flip one side or the other. If you're doing deep space imaging, software like Sequence Generator Pro does it for you. But I don't think that's the case. I really don't know. It's a good question for our SharpCap users and AutoStacker users. Well, Pip would align them right. So yeah, you could use Pip to do an alignment, and that should solve. I wonder if that will solve a flip when half your images are on one side and half your images are on the other. I don't know the answer to that. Oh boy. We're not imaging Jupiter right now, but I can already tell you that if we were, we'd be in clouds, because, well, it doesn't look like it, because PhD's telling me we're losing stars, our guide star. And we have 7 so far attempts to find the guide star. And we'll go back to SharpCap. We will do that. I'm supposed to be working tonight. I have goodness gracious, I've got another 150 images that I've got to get uploaded to the net. And I took this not this Saturday, but a Saturday a week ago at Burns High School. Oh boy, let's go back and see what's going on. I hear all the beeping. According to PhD, we're freaking out over clouds. We got 12 lost stars, our guide star. I'm going to stop this. I'm going to start looping again and see if we can find another guide star. Yeah, pick the same one. One of the problems I mentioned earlier is that the moon isn't too far off, and it's 99.7% illuminated, which means it's a full moon, and it is just flooding the surrounding sky with pollution, and it's just kind of burying the stars. So guiding near the moon at this time is tough to do, and I'm seeing the effects of that. So, but any guiding at all is better than nothing. When you're doing planetary, it wouldn't work at all Oh, the clouds are getting in the way now. It wouldn't work at all if I was doing any long exposure photography like a galaxy or a nebula, and I was taking anything longer than probably anything longer than 30 seconds. The guy started suffering. I'm not sure if that alert's going through to anybody listening or not. I'm hearing it. I can turn it off, but I kind of like to know when it's happening. But it gets nerve-wracking after a while. We lost a bunch. Let's go see how many. Probably 25, 30. At 20. We lost the guy star 20 times due to both pollution and light pollution and seeing conditions. So we'll start again. And let's go back to our live imaging session. We have Jupiter in our field of view, and I'm waiting for the great red spot. I guess the great red spot's going to be coming around. Let's see if I can figure out how to do this. I don't think I have WinJupos on this computer. If I don't, then I can't. Yes, I can. I can open up another computer. Let's do that. Let's go back, bring our software back. Let's go to another computer and let's click on, I've got a computer right behind me here that's and let's bring up WinJupos, and let's go to tools, and if you're I can't say it, that word right there, ephemerides. And let's go to program. We want Jupiter, and we want Jupiter, not this. So why aren't we getting Jupiter? Let's close this out. I really am trying to figure this software out. Okay, there's Jupiter. And we want to have, let's see, today is, we want to do 8/20, today is the 22nd, and the time is, let's see, we want to, the time is almost 11 o'clock, and we want to take 5 hours for a universal time. No, we want to add 5 hours. So 5 hours. No, we want to take off 5 hours. I can't. All right, take off 5 hours. So that would be 6. Is that right? Help me out, folks. If it's 2:30 universal time and we take off 5 hours, so would it be 9 here? Let's see. 0. I don't do this real well. 9. Okay, I think that's what we're seeing now. So if we do 10, let's do real time. We're at real time, and real time is 8:23 UT. So they're already in tomorrow. Okay, so that's what messed me up. Gotta think. So let's add 10 minutes. See how much this rotates in 10 minutes? And so at 7:29, which is that would be around 11:30. 7, 8, 9, 10, 11. Okay, yeah, that will be around 11:30. So 11:30 we should have the spot come. There it is. Okay, 11:30 it is. So I'm waiting for it. Okay, thank you, Wingy Post. Let's go back to the computer that's outside, which is the number 2 computer. And we're still chasing Jupiter. I didn't hear any alerts while I was inside looking at Wingy Post. Let's see if we got any we haven't lost any stars since we last reset this. And so while we're kind of biding time for the next 30 minutes, I use Pegasus Ultimate Power Boxes on my kits. I keep 3 outside, 3 kits outside, and I have 3 of these boxes, and I love them. Not only do they control the dew heater, but all of my data lines plug into the data ports, and I can get information on the connectivity from here, and all of my power lines plug in, camera, focuser mount, flat panel, etc. They plug into the power side. So this hub is the control center for my data and my power, and there's only one cable, well actually 2 cables come out of this, a power cable and a data cable. And of course the power plugs into AC and the data plugs into my laptop outside. And this is capable of I use a different focus routine, but I could set it up to use this to focus. Gives me a reading of how much amperage and current I'm using. Our current is amperage, and voltage I'm using. Also, it will show me where my temperature and my dew point is, and they're already connected. You can't see it, but this dew point and the temperature line have intersected, and there's already dew forming outside. But at any rate, I do like my Pegasus power boxes, so they're awesome. And what else is going on out there? This is my hand controller. It's an ASCOM driven program. EQ ASCOM is the software, and it's good for Skywatcher mounts, the Atlas, Orion, EQ AZ mounts, which is what I'm using now. And I love them. I don't have any real hand controllers connected to my kits outside. They're in here somewhere, but I never use them. I have no need for them. I don't use them. I'm inside, obviously, and these mounts are outside. Let's go back and see. I guess Jupiter's behaving itself because we haven't lost any stars, and we're staying right in the center of things. It's actually almost too bright for me, and I'm going to, this is my histogram. I'll bring up a larger version of the histogram, and I'm going to bring this down to about 50%, and I'm going to do that by lowering I'm actually happy at 93. I'm going to lower the, let's come back. I'm going to lower the gain and manage the noise better. So that's where I'm going to photograph. And so I'm still clicking along at 92 frames a second. And so there we go. I'm going to be looking at something here very quickly. So let's stack it. Saturn is getting some feedback. Okie dokie. We're biding time until 11:30 when the great red spot comes a spinning around. Actually, this is oriented. This is north down here, Jupiter, and this is south up here, east and west. And it's just the nature of how my camera has been attached to the kit. When you see Jupiter jump like that, I have guiding software. Most of you have noticed. I'll go out and show you. We'll go bring up our outside camera. And this is the main telescope, this Smith Cassegrain. And then on top is a guide scope. And the guide scope has a camera attached to it, and it's taking pictures at the rate of, let's bring up the guide. I don't remember what I set it at. Ooh, that's why I'm losing the star. It's a half a second. I want to increase that to, I gotta move this box over here. I want to move this to about 3 seconds. So I want to take a frame about every 3 seconds. Alright, let's go back to where the heck was I? What was I doing? I've lost my train of thought. Well, I have to be on this. I forgot what I was doing, but I needed to. I'm losing my mind. I'm getting old, guys. Oh, we're explaining the guide camera. Okay, let's go back outside. I'm losing my mind. So this guide camera has a job, and it's taking a picture of one star. Now, it normally takes a picture of about. It focuses on about 5 or 6 stars. It's called multi-star guiding. And so it's on one star, and I pick it, or it automatically picks it. And then if the telescope should the telescope automatically tracks in sidereal at sidereal speed, and that's the rotation of the Earth, and which should keep your star centered. But these gears and these scopes are not, they're far from perfect, and so they need to be they have drift, and of course you've got to polar align them and a lot of things in order for these scopes to work at their best, and also seeing conditions have to be good. When you see the planet like Jupiter or Saturn moving around like it does in poor seeing, well, that's what stars do. And if you're guiding, then you're losing your guide star, centroid, because it's moving around a lot. And so what you have to do is take longer exposures, which makes it almost overexposes that guide star, but it helps you to keep your telescope on it. And at any rate, you send this guide camera is attached to this mount. Actually, it's attached to the Pegasus, which connects to the mount, and it's sending corrections to the mount to keep it on the star. So when you go down to this guiding software and you see this red line right here, well, the mount started to drift, and then it sent a correction and brought it back to center. It started to drift this way, and it sent a correction and brought it back to center. And this is in DEC. RA is not getting many. RA is the blue line, and the red line is the declination, and that shouldn't have as big of a problem as it's having. Up here, you can see the RMS for declination is 1.31, and for RA it's only 0.78. So it's a polar alignment issue right now, but it's sending corrections in DEC, and when it sends a big one, then you can see the mount. Well, you see your target jump. So you're sitting here watching Jupiter, and then all of a sudden it jumps real a bunch, and that's just the mount getting a pulse from the guide camera saying, get back on that star, you've moved away from it. And it's what helps center targets over I may image all night long. One target is 50 million light years away, and the scope can't move, and it just can't, or you have blurry pictures. So what you do is you guide and you try to keep it pixel on pixel as much as you can. It's easier to do when the seeing conditions are good, which means the stars aren't moving. It's harder to do when seeing conditions aren't bad. A lot of people think their mounts are not good, or not performing very well, and it's primarily because they probably live in an area where seeing is just not good. And closer you live to the city, even the smaller cities, the more you're going to get the effects of the lights from the city and the heat from the city, heat from the cars, heat from all the asphalt and the radiating of sun back off the asphalt into the atmosphere. And we're shooting low in the sky right now because neither of these planets are very high. I'll show you. They're probably around 25 degrees altitude. I don't need that. I need the planetarium software. So let's find out. Let's see. We got Jupiter here, and Jupiter is right now, let's find its altitude. It's 32 degrees high, so it is not very high. And in fact, it's very low in the sky. There she be. And this is the 30-degree latitude line right here. This green one. And there's Saturn getting ready to. Saturn's closer to the meridian, the southern meridian. The southern meridian just goes to the zenith, and then it goes and it becomes in the north. We'll spin this around, and it's the northern meridian. So it's just the imaginary line that goes from the north to the south over your head. And we can spin this back around again. Come back to the south where we see our targets. Mars has already left us. It's already below the horizon. Or we'd go over and image that. Here's Neptune, and it's not quite 30 degrees. And of course the moon just aggravating. Make sure we got this set to real time. Yeah, okay. And here's Uranus. I thought it was higher than it was. But all these planets move across this ecliptic, this yellow line, which is the ecliptic, and that's the solar path that they take. It sure is, and that changes throughout the year. And this is the celestial equator, this white line. All right, let's go back and see what's going on with Jupiter. And I'm going to just bring up my focuser, and while we're not taking any images, I'm going to just give it's just hard to focus when you're hard to see if you can get a sharper focus when the scene's so poor. There was a correction in the mount. Tell you what, we just go ahead, and since we have an opportunity to do so, let's go ahead and start another 15 stack capture. So I'm going to go to start capture, and I have it set up for 1 minute, and I'm going to take 15 1-minute AVI files, and I'll be taking at a rate of 92 frames per second, which will be about 5,500 frames every minute. So let's start it. We'll take another 50 up. Let's stop it. Stop capture. And let's go ahead and just call this Jupiter, which is what I should have done. Alright, come down here and find Jupiter. Now let's start capture. Oh, it's already started. Thought I stopped it. I don't know what this one will be named, but it'll be the 16th. Jupiter video file, because we took 15 the first go around. We are live imaging if you're just joining us. Jupiter. We did image Saturn earlier tonight, and we're waiting for the great red spot, which is about 15 minutes away, I think. Tell you what I'm going to do. I'm going to check with another, get on my phone, and where did I just see that? 11:30. So come on, great red spot. That's what we're waiting on, and that's the giant storm that's about 400 years old, that's been cooking on Jupiter all that time. You could put a bunch of Earth-sized planets inside that storm. It's huge. It's like a hurricane. The winds in it are crazy wild. You probably already know that Jupiter is a gas giant. It does not have a surface like Earth. Methane and all kinds of gases from your chemistry periodic table make up this. It makes up Saturn. Mars is one of the few Earth-like planets that it's not a gas planet. Do a little adjusting and considering. I'm curious as to how we're being named now. Let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. These two right here are a result. No, that's what we took. Here's Jupiter. Okay. We've got 3 Jupiters here. Okay. So it did take the name. Okay, good. If perchance the great red spot rolls around, I'm going to go ahead and stop the current run and start all over again and get 15 files of Jupiter, if the clouds let me. I'm headed over to Fair Forest Middle School tomorrow, and we're going to sit down and order telescopes, mounts, and all that goes with astronomy, astroimaging, just as in astronomy in general, for the observatory that has been built, the domed observatory at Fair Forest Middle School. It's huge. It's going to be awesome. We're buying state-of-the-art equipment, and it's really going to be something special the kids are going to have. The district is also going to be negotiating so that it can control telescopes in different parts of the world, giving the kids an opportunity to see what's going on during the day in parts of the world that are in the middle of the night. And so Spain, Hawaii, and then we have the southern hemisphere, and depending on where you are in the southern hemisphere, if you're in Australia and New Zealand and that area, then what you see at night in the sky is altogether different than what we see in the sky. The closer you are to the equator, the more you're going to see what we see. And but even when you're in the northern hemisphere, if you're down close to the equator, you have some limited views of what. We're in a very fortunate place in the northern hemisphere, geographically speaking, living in South Carolina, because our latitude is 34 point. My latitude, where I live, is about 34.85 degrees, and so pretty cool. But our weather's pitiful, and we live in some light polluted areas. And light pollution's not going to get better, it's going to get worse. Development and more development and even more development is happening everywhere. Specifically in the South, we're becoming an attractive place for businesses to relocate. We have good, plentiful labor, and we work for less, I guess. Come on, great red spot. We're getting close to 11:30, and we should start seeing it if it's going to happen. The reason I know I'm not 100% accurate with what I'm getting ready to say, but I'll look it up before I say anything. But Jupiter, I believe, makes a complete rotation in the neighborhood of 8 hours. So about every 8 hours, Jupiter makes a spin where we take 24 hours to rotate completely and change. So when you're imaging Jupiter to have a sharp image, there's a problem, and it develops. It rotates, and so there was a correction in PhD just happened then, and so you have to derotate the images so that you can combine them. Here's that spike, that correction we just saw that moved Jupiter a bunch. Well, Taurus, my friend in Greenville, we predicted, I think you told me 11:30, and we're getting close to that now. We're at 11:27, and it ain't come up yet. See, we're at 4,900, 5,000 frames. We're going to be about 5,500 frames, and then yep, 5,548 frames is what we're taking. And the scene conditions actually has gotten a little better. I don't see Jupiter ricocheting all over everywhere now, and the clouds seem to be giving us a break. I hope they just stay away. As long as they stay away, so we can get some good, great red spot video captures, excuse me, I'll be happy. Taurus, if you're out there, I think we calculated wrong. If I think, since this is north, I think it's going to come up over here. Now, is my guess, and that's where I'm looking. If you join us, we're live imaging of Jupiter. We've been doing this for an hour plus, maybe an hour and a half. We did take a number of pictures of, tell you what, while we are waiting, let's bring up Auto Stacker. Let's see how these Jupiters are looking. Let's go to Jupiter, and let's take the last one they did, and we open it up, And let's clear this out. Let's kind of scrub through this. Ooh, I like it already. And let's analyze. We'll just process this one while we're waiting. Biding time. And again, I apologize, this laptop. Well, we have more below the 50% line than we have above, because this line right here intersects about, this is at 25, this is at 50, so we're about 30%. And so that isn't good. I would have thought it would have been a little better. So what we're going to do is we're going to go over here and apply our alignment points, and then we're going to come up here, instead of 25, let's do 20%. That'll be about 1,000 frames, and let's stack those and see what happens. Okay, we are at 11:30 and waiting on the great red spot, and I don't see it yet. Do 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 do. Well, we're having fun anyway. I can sing. Terrible, but I can sing. I'll take requests. Okay, we got those 15 out of the way, so it's over with. Capture complete. Alright, let's bring auto stacker back up. And we're stacking. About done. And that did it. So we can now rest that to sleep, and let's bring up Registacks. And that was our Saturn. Terrible, but it's what we got. Now let's go to Jupiter. And let's bring this one into Registacks. No stretch. Okay, let's go over to RGB balance and let's auto balance. Okay, let's go to flip, and we want to flip that so that the north is north. I thought I had it right. You know, we're going to leave it there. And then we're going to go to the histogram, and we're going to brighten up things. Come on, slider, grab it. We're going to go to about there and stretch it. Hope it isn't too much. Okay. And then we're going to go to the curves, and we're going to apply this curve. I may add a little more contrast than I did on Saturn. Okay, doke. And then let's go down to our wavelets, and let's load Jupiter. And there we go. So All we need now is the great red spot. And it's coming. I need to rotate this the other way. I got it upside down. Right. Okay, let's do that. Alrighty, we'll do all. And we'll save. I want to add to this. Uh-oh, there's that noise about the clouds. REG. I'm getting an alert that we're losing our stars. So let's bring up PhD and see what's going on. Well, I thought we got an alert that we were losing our stars. I don't know what that alert was for then. Let's go back to come on, great red spot. Let's go ahead and run another capture series. Let's go to start capture, and we're going to do this again. We're going to take 1 minute. We're going to take as many as we can, and let's just go ahead and set this to 30, and it will run through for the next 30 minutes plus. This is a little downtime between videos, 3 or 4 seconds, so if there's going to be a great red spot, I'll catch it in the next 30 minutes. If not, then Taurus, we were miscalculated. I got to do a better job of converting Universal Time, UTC, to Eastern Standard Time. Eastern Daylight Time, which is -5 hours from UTC. That's all you do is just take 5 hours off of the UTC time. But when it gets confusing because UTC, it's already the next day, and so it might be 1 or 2, and so you got to go back to 12, and then well, what it is. I think we missed this one, Tars. That's on me. I'm going to go back to my streaming software, and I'm going to bring up something here real quick. While that's doing that, and then we're going to go back to our screen share, and that's going to take us over here. There we go. So we are now just gathering data. We're taking 5,500 frame AVI files of Jupiter, live imaging of Jupiter tonight. We did Saturn, and it was the scene was not good. The scene has gotten better. Also, Jupiter's moving away from the moon, and that helped a little bit. It did. I need to do a couple things. Do. We are live imaging. Come on, great red spot. Where are you? I think we just miscalculated. Taurus is the name for a friend of mine, Alan Hill, that lives in the Greenville area. And he's one of the bold leaders of Roper Mountain Astronomy. And I think he and Josh Palmer and a few others are out in their neck of the woods from Gray Court to Simpsonville. And they're also imaging Jupiter. And we talked about earlier today when the great red spot was going to show up, and I think they figured it would be at 11:30, and that seems right, but it didn't here, so I guess it's wrong. I'm taking 30 images. I'll take for the next 30 minutes, and I got a big day tomorrow, and I got to finish these football pictures that I'm working on tonight, and that's these. This is from Saturday a week ago. I did get the Clover game up, but I've got to do, and probably 100 more to process and then upload to my website. But I want to get this great red spot if it's going to show up first. It's gotten real sharp and clear, and the scene has gotten so much better. Taurus, I hope you are imaging. I need to send them a message and tell them if they're not, that they need to start. Because I heard them complaining about the scene conditions earlier. Things are looking pretty good right now. With the exception of the great red spot, which is nowhere to be found. Let's go ahead and process the last image that we've done, because the scene has gotten better. So let's bring up AutoStacker, and let's go over and find the last one we've done here, which will be this one. Clear that out. Yeah, actually that looks pretty good. Scrub through this. I'm going to just leave it. Okay. Right there. So let's analyze that. Again, I'm using a program called AutoStackered by Emil Krykamp, and brilliant software that's going to go through each one of these individual frames in this AVI file and rate them, and it already has done that. And roughly, this is a better, you can tell scene's gotten better because about 60% of my images, this is 50%, this would be 75% line, so about 60% of my images are above this line, and which is a halfway line, 50%, and then 50% are below it. These aren't usable, and the ones above 50%, well, those close to 50% are not usable. So out of 5,000 frames, I'm going to keep about 25% of these. So let's go over here and set our alignment points, and I'll let the software do it for me and stack. So what's going to happen, it's going to only take the top 25% of all the 5,000 frames I took. It's going to take the top 25%, so roughly a fourth of 5,800, and it's going to stack those into one image, a TIFF file, and it's going to save it for me automatically. And then I'm going to go get that one image that has the best of the frames stacked, and I'm going to apply wavelets, which is like a sharpening effect at different levels of structure, and I'm going to apply the wavelets along with some other tweaks in a program called Registax, which is also free. Now Emil with AutoStacker does ask for a donation, and I have about every year I send the equivalent of what I send for SharpCap. SharpCap's free also, but if you buy the pro version, you have access to some other things that are pretty cool, and I think that's $20 or $25 a year. So a lot of this software was written by people like me, not that I could, but astronomers, amateur astronomers, who's trying to figure out a way to do the things they wanted to do, because there's no market for our hobby. How many people do what I do? And in this town, maybe 4 or 5. Maybe I'm the only one, I don't know. So there's just that companies aren't going to go out and manufacture this kind of software because there's no market for it. There's not that many people doing this. So, well, we're done with this, so let's bury it and let's bring up Registax. Still don't see the great red spot. That was our last attempt. So let's go to Jupiter and let's bring this one up. That one we've already done, and open it up. No, we're not going to stretch it. And we're going to go over to RGB balance, and we're going to auto balance, and then we're going to shift it around a bit, tilt it about there, and then we're going to go to histogram and we're going to brighten it up some. Let's get rid of this. Let's bring it over a little more, about there, and that's probably a little bit too light, but I'm going to dumb it down some with levels. and with this curve adjustment, that's okay. Let's bring it. Don't need that. Don't need that. Let's go over and apply our Jupiter. And there's our second attempt at Jupiter, and that's somewhat better. So I was looking to see if the no great red spot yet. Okay, let's head back to our acquisition software, and we're still capturing. We were going to do about 30 frames that last a minute, so 30 minutes of continued capture. I may go to 12:30. I'll probably end this video because of its length anytime now. As a matter of fact, it's probably time to end it. If you have been watching this and you like it, if you don't mind, let me know that you like it, and consider clicking like and the bell. And then if you want to see more of these, if you subscribe to this channel, then the next time I go live, you'll get a little email that'll pop up, and particularly if you click that bell that's telling you that we're either going to go live at some point in time or a new video has been uploaded, and you can see what we're doing. So consider subscribing and liking, and I would appreciate it. Until we meet again, folks, I hope everybody has a great week this week, and it's careful that you stay COVID free, and make sure you say something good to somebody tomorrow and lift up their day.